Hello friends, I'm Dr. Rupali Endait, Assistant Professor, Department of Chemistry, Radhabai Mahila Mahavidyalaya, and we are seeing agricultural chemistry. In that, we have to see quality of irrigation water. Now, see the introductory part about the water. As we know, water is one of the most important commodities which man had exploited than any other resources for his life. Most of the water on the earth is stored in oceans and ice caps, but which is difficult to recover for our needs. The question is that what is pure water? For all practical purposes, a pure water is considered to be that which has low dissolved and suspended particles, as well as gases and low biological life. That water we can say pure water. Such quality of water is required only for the drinking purposes. Water is usually classified as hard water and soft water according to the concentration of calcium and magnesium ions in it. The water is also called as carbonated, sulfated or nitrated water depending upon the concentration of their ions. Then we see sources of water. There are total main 4 sources of water. First one is the atmospheric water. Second one, surface water, stored water and groundwater. See the atmospheric water. Rainwater and water formed by snow are termed under atmospheric water. See surface water. Water that collects on the surface of the ground are called as the surface water and, for example, river water. Stored water. Water which is present in ponds, reservoirs, lakes or oceans for a considerable period are called as the stored water. While when water meets rock that has no porosity, then that water is termed as groundwater. The saturation of water in the soil at particular level or a zone, that zone is called saturation zone, and the upper boundary of zone of saturation is called water table. Impurities in water. Anything in water that is not H2O is a contaminant or impurity. All water is impure and it is the principal job of the water chemist to define these impurities, set specification for each impurity acceptable for the use of the water after treatment and devise economical treatment methods to reach the quality limits that have been set. Water quality contaminants in raw water. The unique ability of water is to dissolve, and the raw water contain many contaminants. The major impurities found in raw water is suspended particles including colloids, dissolved inorganic salts, dissolved organic compounds, microorganisms and dissolved gases. Now see these all contaminants one by one. Suspended particles. Suspended matter in water includes silt, debris and colloids. Colloidal particles which can be organic or inorganic and not truly in solution or suspension, but it gives rise to turbidity to the water. The degree of colloidal contamination can be determined by 2 methods. First method is the Falling Index method and second one is the turbidometric method. Now see the first method, that is Falling Index. In the Falling Index test, raw water is passed through a standard filter and the rate of blockage is measured. Greater the rate of blockage, greater is the amount of colloidal contamination. See the second turbidometric method. This method determines total suspended solid content of the raw material. And in this method, Passing a beam of light through the water and measuring the proportion of light scattered from the suspended particles, we can find out the contaminants. Then we go for dissolved inorganic salts. Dissolved inorganic substances in solution include hard salts. The bicarbonates of calcium and magnesium gives rise to temporary hardness to water called temporary hard water, while the sulfates and chlorides cause permanent hardness and called permanent hard water. The other inorganic impurities present in water are carbon dioxide, sodium salts, silicate, ferrous and ferric ion compounds derived from minerals, phosphates and nitrates from detergents are present in raw water. How is the amount of dissolved inorganic measured? It is measured by using the term total dissolved salts. This TDS is the residue in ppm obtained by the traditional method of evaporating a water sample to dryness by heating it to 180 degrees Celsius. This residue includes colloids, non-volatile organic compounds and salts which are stable at this temperature. That means the greatest proportion of residue is inorganic salt and TDS used as an indicator for the total level of inorganic compounds present in feed water. It can be measured directly or estimated by multiplying the conductivity of water. Then we go for dissolved organic compounds. The humic substances found in great amounts in swamp waters, which impart a yellow or brown color. Contamination on raw water by organic substances is mainly due to dying of and decaying of organisms as well as swelling in water. Unpurified wastewaters discharged by industries into water reservoirs. All the organic substances present in water are not in colloidal state. Some of them may be present in the form of true solutions. Then next contaminants is microorganisms. Biological impurities are present in water. Biological contaminants may be microorganisms, bacteria or viruses. Chemical treatments are typically less effective against microorganisms than boiling and filtering. Coliform and E. coli are bacteria, sometimes found in water, that may be contaminated with animal or human waste. Boiling and chemical treatments are typically more effective against bacteria and viruses than filters. Then we go for dissolved gases. All natural waters also contain gases, of which oxygen and carbon dioxide cause corrosion of metals. Thus, treatment of boiler feed water must include degasification. Dissolved gases such as oxygen, carbon dioxide, etc. may be present in water as impurities. And for the removal of these gases, it is better to classify them into two classes. First one, gases which are removed when the solution is heated, because solubility of gases in water decreases when the temperature is increased. And second class is gases which can only be removed by chemical treatment. For example, oxygen from water may be removed and passing water over hot iron. As a result, iron is oxidized to ferric state and is precipitated like this way. Acidic gases can be removed by treating water with calcium hydroxide or calcium carbonate. Physical, chemical and biological characteristics of water have to be analyzed both qualitatively and quantitatively in order to evaluate water quality. The knowledge of water quality and its contents are essential for judging its suitability for various purposes like public health, irrigation, industry and environmental safety. Related problems in public health, environment and agriculture. First, we focus on drinking water standards. For domestic use in India, agencies like the Indian Council of Medical Research, that is ICMR, Bureau of Indian Standards and Ministry of Works and Housing have formulated certain drinking water standards which are being followed by different authorities. The World Health Organization has also laid down drinking water standards. It includes the characteristics, physico-chemical standards, in which turbidity, color, taste, odor, pH, total solids, total hardness, and other dissolved inorganic impurities have to be considered. Second one is the bacteriological standards. It includes coliform count, E. coli counts, and other microorganisms. Irrigation water standards. And agricultural chemistry. We are interested to study the quality of irrigation water and irrigation water standard with regards to the quality of water for irrigation for a variety of crops. The major parameters of concern are salinity, potentially toxic trace elements, and group of other miscellaneous problems. The presence of sodium is also an important parameter, the excess quantities of which can deteriorate the soil. High value of sodium may also damage the sensitive crops because of sodium phytotoxicity. See the salinity. Salts in soil or water reduce water availability to the crop to such an extent that the yield is affected. It is denoted by dissolved solids and conductivity of water. Water infiltration rate. Relativity high sodium or low calcium content of soil or water reduces the rate at which irrigation water enters soil to such an extent that sufficient water cannot be infiltered to supply the crop adequately from one irrigation to the next. Specific ion toxicity. Certain ions like sodium boron or chloride from soil or water accumulate in a sensitive crop to concentrations high enough to cause crop damage and reduce yields. And other factors, excessive nutrients reduce yield or quality. Unsightly deposits on fruit or foliage reduce marketability. Excessive corrosion of equipment increases maintenance and repairs. Thank you.